Good morning, happy Monday. Hello, hello. Uh, I am happy to be relatively on time today. But let's see where we're at. I believe we got it to the point where we can now create we can create entities, at least with one component. So we have the location. And we're sort of like drawing that on the screen. And I think we have that mesh in the resources as well, which is really helpful. And I think we're using this mesh and not this mesh. So I'm going to go ahead and delete that because we don't need you. Yeah, we don't need you. Okay, so the next thing is I want this human to sort of like just be wandering around randomly, like as humans tend to do. We wander around. So random walker essentially. Well, what that means, we have a location, but we're also going to need a velocity and an acceleration, so that way we can update those values. So let's go ahead and in our components, okay, we have location, we'll create a velocity .rs and acceleration .rs. And for each of these, it's pretty much exactly the same thing. We're going to use this vector too. And I don't know if, well, I guess like we should probably just do the exact same thing as before. So we're going to impl deref. So if I take this entire thing and we also copy it into acceleration, you're just going to be acceleration, that. But besides that, they're exactly the same. Okay, so that means what we can do is we're gonna have to have a speed. We might have to have a speed for this too. In our main library, we're gonna add this one. Okay, so world register entry with component. So I think we learned that we can make this like smaller. Like let's try a 10. So we have this location. We can put this. Let's put this in the exact center. So we have this arena size. Oh, entity size. You actually need to go in here. There we go. And then you are gonna be changed to the arena size. So the arena size dot x size dot y. Oh, width and height. Let's go fix, okay, resource. We can have this derive copy. and that will make it just automatically, so I don't have to manually fill in it. It will just copy over. Okay, so we have with component. So our next one is going to be the velocity. And that would be correct. We're gonna just have you, and then with components, this is gonna be our acceleration. And you're also empty like that. Oh, right, and I keep on forgetting, for each of these, we have to make you public in here. Hi. Hi. We have a Zombie. Sort of. Hanging out a little bit below where the camera can catch him. Okay, so we have you be publics, then you're happy here. Okay, so we have all of these things. So then we're gonna want a system to choose a random direction and update our acceleration, and then another system to update our velocity, and probably finally a third system for updating our location. So let's do it. We're going to, first of all, if we don't have it already, we need rand. Then in systems, let's create, this should be our, we're gonna update the acceleration. So maybe like randomly walk. All right, so randomly walk. There's pretty much nothing in there, so we're gonna have just an impl for this. Now, for you, what am I gonna care about for this? Let's see. Our randomly walk should take in... Basically, we just need the world. And then after that, I don't think we need anything. We're just going to use rand. I don't even know... I think we're going to require a result. Okay, so the first thing we need to do is we need to get everything that has an acceleration. So we just basically need to get all the accelerations. Now, something else I'm thinking about, we want to have a bunch of humans walking around, right? And the zombies are going to move. Do they move in the same way? They probably also randomly move around too. The difference is going to be when they see a zombie versus when they see another human. Okay, so then this should be fine. So we need to query for all the accelerations. Let's see, how do we do that again? But our query is going to be dot query right. That gives us that, so we can then do with component, and we want the acceleration. And pretty much then just run, right? Now, is there anything that I want to do here to like stop ourselves early, right? Because we can update our query to make sure that we only get things if they're in a certain state. So, for example, if they see a human, yeah, let's not do that. But we can update this query pretty easily when necessary. All right, so we get this with our vec. So then say I want there's only one of them, so I don't need to worry too much about that. So there's going to be accelerations equal to query of 0. Now, why can't you see what that is? Because that's output. Okay, so that should be a vec. So that should be this vec right here. A vec of this RC dyne any. But you can't figure that out. Interesting. Okay, so if we have that, then I want to loop through the accelerations. Oh, as try okay. Oh, it doesn't return. Oh, right. Okay, never mind. I thought it was returning a result, but apparently I had removed that and I forgot. Okay, so we can iterate through this. So we have this RC. So, oh, in this case, I think I can just take ownership of it, can't I? So we have this RC. Then I want to borrow that. Okay, so we borrow you. That gives us this ref dyne any. Then we're going to need to downcast this to whatever it was previously. So this is a wrapped acceleration. Okay, so then this becomes our actual real acceleration. So acceleration equals our borrowed acceleration dot downcast. This is going to be mutable. And we're going to say you are a acceleration. Now, is there anything on an option that I can do to convert it to a result? There is right here. Okay, or transforms the option into a result, mapping some v to okay and none to error. Okay, so if I do okay or, this wants to take in an error. Oh, okay, or else maybe? Oh, no, wait. Okay, so it's going to call this as a function. Do we get an error in here? I don't think we get an error in here. I think what we can do is, right? Okay, or else doesn't. Yeah, okay, so it's an error function. Output is an error. So I think, does bail allow us? No, it wouldn't be bail. Maybe it would be. Okay, then we can take this and question mark that. Okay, so it doesn't like bail. Because you... the treat bound, standard result, error report, standard error. Oh, okay, so it's the wrong kind of error coming out. So you need... something that just creates an error. Is there a, let's see, the core error reporting type. Construct an ad hoc error from a string. Okay, so maybe anyhow would be. There we go. Okay, so that makes that happy. Now with you... Oh, acceleration needs to implement debug. Okay, then we get this query. cannot move out of this. Okay, so I don't want to. That's fine. Borrowed acceleration, cannot borrow data or dereference. So you are... So we borrowed you. So you're this Reftine any. Oh, we want to borrow mute. That's why. Okay, and you need to be mutable here. There we go. Okay, now we have access to this. So we have our acceleration in here. It's a mutable reference to an acceleration. And now I want to create a random vector to add to it. And for this vector, do I care about how strong it is? I probably do. So let me think about this. If I want to take this acceleration, I want to add to it. So I think we're going to need a speed. Because I realized that I can actually go into our vector 2 for here. We can add a hub function. Actually, it would be up here. We have this new. Let's do new random. A random range. And we can have minimum and maximum, which returns then self, okay? Not quite. There we go, okay. So we have rand, so we can use that. Oh, and I think I can actually do that here too. So let mute RNG equals rand. This is gonna be the thread RNG. Then okay, so we can get the X with RNG gen range. There we go. Okay. Then we get the Y, and then we're going to return self X and Y. Oh, you don't know how to do the normal thing anymore. Oh, it's so close. Just missing that as like a range. Okay, so then we come, so we need a speed, right? But if we come back here to randomly walk, let me do let random random speed. It could be random direction. Equals, this is gonna be a vector 2 new random range. Let's just do like negative 1.0 and 1.0. That gives us this vector 2, and then I want to add to this acceleration. So how am I going to do that? I'm going to come back into vector 2, and I want to make it so I can add a sign. So we're going to take a right-hand side. We're going to take ownership of that. That's going to be fine for this. We're going to do self.x equals right-hand side of that x. Yes. Self.y, right-hand side of that y. Okay, perfect. So then we're going to do acceleration plus equals random direction. Oh, and you're at mute, so what I can do is dereference you. Oh, do I need to do like the double dereference? Cannot borrow data in a dereference of components. Acceleration. Acceleration is mutable trait. Deref mute is required to modify through a dereference, but is not implemented. Oh, can I do that? So can I derive deref mute? Oh, it doesn't even know where this is. I don't think I can. So we're gonna have to implement that ourselves. So impl deref mute or acceleration. Okay. Interesting that I don't need to do the same thing here. So I think target equals this vector 2. And our target is going to be a mutable reference to self.0. I guess I don't need to do that. Okay, back to randomly walks. Hey, and it's working now. Okay, so I have to double dereference because first of all, I've got this just mutable reference to acceleration. And then once I have the acceleration, I have to dereference that to then be able to mutate it. And then I can do this add assign. Okay. That should update our acceleration now. So then we're going to want another system to update our velocity. All right, so how are we going to do this? We need to query for the world. No, we need to query for accelerations and the acceleration and the velocity, and that's it. That's all we really care about. So now I guess like what I can do is before I actually finish doing this, let's now like run this. So an update. We need to do the same thing that we have here. So let update. Oh, I guess this is randomly walk. So randomly walk, and then we're gonna do randomly walk that run. Randomly walk definitely has a run on it, and it's public. Why can't you see that? Oh, I know why. Because we don't have a self on it. Then that makes this happy. Okay, so we're running this. Okay, so update velocity times. Now we want to query for velocity, anything that has a velocity and an acceleration. So okay, so with component, we need an acceleration. And a velocity. And then we run that and we get our vec of x. So then we can just do that accelerations equals query of 0. Now I probably don't want to take ownership of this, but it might also be okay. That velocities equals query of 1. Okay. Velocity doesn't implement debug. Cannot move out of there. That is fine. Now I could just clone these, can't I? Yeah, cloning this is just fine because it's like super it's pretty simple. No wait, Lisa. What am I saying? I can just clone them because RCs are practically free to clone because they're just smart pointers. So I'm cloning a smart pointer, but not the actual data. And then I have ownership of this, and then, yeah, it's going to be fine. So now I want to update velocities. Okay, so we need to loop through each of these. Now we should build, like, we should always have the same number of these, but let's just do a quick assert. So that way, in the case that, like, for some reason it's not, we're gonna do the accelerations dot length is equal to the velocities dot length. And so if for some reason they're not equal, I want it to crash like immediately. All right, so then let's go ahead and loop through all of our accelerations. So for index acceleration, I mean, it's not quite as simple as that, but I mean, that's what it would be awesome if it was. But okay, so we have acceleration, which is this RC. So then we want to borrow this. Okay, so And we're going to, okay, so we're just going to do this borrow here. We need mutable access to the velocity, though. Okay, so velocity is index. And we're going to borrow mute. Okay, so then we need to downcast them. We can't do them the same. We can't do that at the same time as the borrow. Okay, so borrowed acceleration. We're going to downcast just as a reference. We're going to downcast to acceleration. And then we're going to use this okay or else so that we can get this anyhow. And then we'll just say air downcasting to acceleration. And that allows us to question mark it. Hello, Lumicode. How are you doing today? I'm doing good so far. Now we need to do the exact same thing to the velocity, except velocity is going to be mutable. So velocity equals, okay, so it's going to be our borrowed velocity dot downcast mute. And then this is going to be a velocity. And we're going to say okay or else is any, okay, so that seems to be good there. Okay, now we have this specific acceleration and this specific velocity. Then I want to now add the acceleration to the velocity, but we already have that set up for us. So we can just do a double dereferenced velocity plus equals just acceleration. So velocity plus equals acceleration, and that's it. But we do have to dereference u to get at the actual thing. Oh, we have to double dereference here. Cannot borrow data in a dereference of components. Oh, deref mute for velocity as well. And then you cannot move out of a dereference of components. Okay, so no, okay, hold on. I want none of those things. Hold on. So what do we have here? For acceleration, we have a reference to, okay, so a dereference that should now give us, okay, found struct acceleration. So then I want another dereference gives us cannot move out of dereference of acceleration. Oh, okay, we need the copy trait or to clone it. That's what needs to happen. So in acceleration, we need to clone and copy. And that handles that. And that should update our velocity now. Let's see. Oh, does vector 2 not implement clone and copy? Well, let's fix that. Yeah, you don't. Okay, no errors. Then back to the main library. It's time for us to now update this. So we're going to do let, I think this was just update velocity. Update velocity. So we randomly walk, which sets an acceleration. Then we're going to update velocity dot run, and same exact thing. And did I just do the exact same mistake here? I did. Okay. After we update the velocity, we have to update the location. Okay, so it's going to be very similar here. We're going to query for the velocities and the locations. Wrong kind of query. So we want the velocity. And we want any location. And I think that's it. Okay, so now I want to loop through all of these, so it should be fine. We're gonna do location. Let's see, how do I want to do this? Probably the exact same way. So we're gonna do let velocities equals, okay, this is gonna be query of 0. We have to clone you. Okay, so we do that. And we're going to loop through all the velocities. And this is going to be a wrapped velocity. In velocities iter enumerate. Okay. So that gives us that. We're going to now unwrap the velocity, and yes, that is going to be just a normal unwrap like that. Long type of result. Wait. No method named, oh, it's borrowed. Sorry. This is gonna be a borrowed velocity. And we're gonna borrow you. Okay, that gives us that ref. So let's do borrowed location, locations of index. We need this to be mutable. We're gonna borrow you mutably. Hello, Chantilly. How are you doing today? Okay, so now we have both of these things. Time for us to actually just do our. Okay, we need a downcast then. So let our velocity is going to be equal to our borrowed velocity dot. I think we can just do it like this. So downcast ref. Here, velocity. Okay or else. And this is going to be, we're going to use this anyhow. So we can say pair casting to velocity. Okay, so let location. This is gonna be, yes, borrowed location. Oh, and you need to be mutable here still. I'm pretty sure. We're going to downcast mute. I'm doing pretty good. It's the beginning of the new week, so it is a Monday, but so far it's been nice. Okay, so then, okay, we have that. So now we have our location, we have our velocity. Oh, and we need to question mark this. Okay, so with our velocity and with our location, now I want to take our location and update it to this. So we're gonna say location plus equals the velocity, but it's not gonna be quite that simple because they're the wrong types. So we double, we do that, and then you, deref mute on location. All right, that should take care of that. We should head back to the main library. We should head back to our main library. Okay, then we're gonna do the exact same thing here. Okay, so we update the locations through all these different things. Let's, I think at this point in time, it should be able to work. Just sort of like as expected. We do have an error though. Where's our error? Oh, you're in a library. We don't care about that. Let's run this, see how it goes. I could swear I saw something like way down there. You know something else that we need to do for update here? We need to limit our update. So let's create a resource. And we'll pass that in through our main state here. So in new, we're gonna have the FPS, the target FPS. Yes, I think that's a U32. Then we can add this resource. Our resource is going to be, oh, we need to probably have our own resources. Target FPS. Okay, target FPS, but you're gonna just hold U32. You need to be public here. And let's implement, let's see, we should derive debug, and we should impl deref. Hold on. Just deref. Okay, equals, yes, it's gonna be U32. So you're gonna be a reference to self.0. Okay, so then back here, add resource. We're gonna do a target FPS, and we're gonna throw in target FPS. And then in main, we just need to figure this out. Let's say, yes, we're gonna be 60 and pass that in here. Okay, then in update, we need to actually get that out. So get resource, which I think is this. We're gonna be getting target FPS, and we know it shouldn't cause a problem, but we can just go ahead and unwrap it here. Okay, there's a target FPS, and then we're gonna do our while. So timer. Okay, this is an update. That's the context, and then our target FPS. And then all this stuff happens inside of it. So that way we're now locked to 60 frames per second on the update. We can draw a lot faster than 60 frames per second. You need to be dereferenced. Expected. Oh, you need to be double dereferenced. Okay. Then I think we're good here. All right. So let's go ahead and run this again and see what it looks like. It's still moving way too fast. Let's go into our updates. Oh, it's like, it's move, right? Randomly walk. We're going from -1, so let's go like negative, like 0.1 to 0.1. And let's see what that number gives us. It is nowhere. Do you have to go even smaller? I'm actually kind of curious what we're getting here. I want to, in the display, or the draw. So we're getting all these locations. So borrow location, here's this. I want to do just a debug really quickly of the location. I just want to see what it is that we're working with. There's only one entity here, so it should be fine. Okay, so it's changing, and it is outside of the bounds, and it's moving really fast. Like way too fast. Oh, you know why? Because we need to reset our acceleration. Oh, I almost forgot about that. In fact, I did forget about that. We need to have a reset acceleration. So we're not constantly adding to the acceleration, which then adds to the velocity, which gives us very fast movement. So in this case, we're just going to query for all the accelerations by themselves, and then clear them out. I think I can just do this. So, okay, that gives me that. Here, a wrapped acceleration. Then I want to... okay, so for this wrapped... Okay, we need to borrow mute now. So let... Okay, so we have that. Now I need to downcast. We're gonna add in, this is gonna be the okay or else. All right, so in this case, I want to error stating error downcasting to acceleration. Then we can question mark you. Okay, so now we have this. Now we have this acceleration. Then I want to just clear and empty you out. So this should be fine. So we're gonna go find acceleration, and I want to do I want to do this on vector 2. So on vector 2, I want a clear. We're not going to return anything, but we're going to empty out what this is. So self.x, self.y. Okay. So now that we have this, we should be able to do acceleration dot clear. And there we go. That should do it for us. So we're going to head back into the main library. Grab you. What did I call this again? Reset acceleration. Reset acceleration, run all that looks great. Let's try running this again. So, okay, it's updating a lot slower now. But those X's and Y's look like they should actually, oh no, here it is. There it is on the screen. So there it goes. We have it randomly walking and moving around now. Now, let's say that we want to keep our humans in the actual world. So we need to prevent them from moving outside. What is that going to look like? That's going to be another system where we're going to have stop entities from leaving the world, contain entities in arena. Okay, so once we're to this point, what do we need? We're gonna need the arena size, and our locations, and we're also gonna want to stop our velocities, right? We want like you hit the wall and that just stops you dead, at least in the direction that you're moving. At least I sort of feel that's how it should work. So we need the arena location. So let's get that first. Okay, so we have our arena size. I wonder if I can like just deref it here too. No. You don't seem to care. Okay, so we have our arena size. Now we need our locations, and we're gonna need the velocities. So if you have a location and you have a velocity, there's a possibility that you're going outside the zone. So okay. Okay, so we want a velocity. And close, that's a location. And then that's it. All right, so we have this now. What's next? That's our... We then want to extract, okay, so we'll get our velocities and locations out separately. Okay, so this is gonna be our query of position 0, and we're gonna clone it. So let's also get our locations. Okay, that's correct. Now we want to loop through all these. This is going to be our index and a wrapped velocity. And velocity is the iterate. Okay, yeah, that's correct. Then, okay, so velocity. Okay, that's not exactly correct. So we're gonna do let. We're definitely gonna have to have this be mutable. So mute borrowed velocity. It's gonna be equal to our velocity or wrapped velocity dot borrow mute. Okay. Then we're gonna want to, yes, we need to get you mutably as well. So our borrowed locations, okay, That's exactly the same. Because we're gonna have to reset the location just ever so slightly to make sure it doesn't clip inside the walls. Okay, so then what do we need to do? For each of these locations, we need to check to see if our X is greater than, okay, so we need to check like the right, top, left, and bottom sides, and then reset ourselves if necessary, and then reset our velocities too. So if our, oh, we need downcast. Wait, we need, so let velocity is going to be equal to our borrowed velocity dot, so let's, okay, we're going to downcast mutably. It's a velocity. And then we're going to do an okay or else with this anyhow. There you go. Okay. Kind of get it. All right. So let's now get location equals borrowed location. So that's a good first start. Downcast mute location. Okay or else. Anyhow. Yeah. Okay. You got it. Then, now we can do our checks. Okay, so if, oh, we need the component size, don't we, too? Do we have that? We have this entity size here. We have a mesh. Okay, so we have the mesh, add resource. Okay, so we're gonna need add resource for entity size. We have this here. Okay, so you don't need to be any of this stuff. We just need you to be self. So you're going to turn a, actually, I don't even think we need, here, just be hub that. We're going to import deref. For entity size. Oh, come on. There you go. Okay, so you're going to be an F32. So then you are going to be a reference to self.0. Okay, this entity size. Okay, you need pub mod entity size, inner main library. We're now going to add you as a resource. So add resource, entity size, and then the entity size close. That. Okay, so then contain, okay, so now we can extract this out as well. So we'll do that right here. Okay. Yeah, exactly that. So now we have our, okay, so we have the entity size and the arena size. All right. So now I believe we should be able to do this. So if, let's do if our location dot x, so if the center of us plus half of our width is, let's do the right hand side first. So if our location dot x plus half of our width. Now I might be able to do in this, we can do some impulse in this. So impl entity size, let's do hub function half. What? Okay. Self dot 0 divided by 2. There we go. Okay, so if location of x plus our entity size dot half. Okay, so half our entity size. If that is greater than the arena size dot width. I mean, you're correct except for that or. I think. Yeah, because we need to just do this first. Okay, so if we're clipping over the right-hand side, so right-hand side over that way. We want to reset our location. So we're gonna have to set the location dot x. We need to now set you to the arena size dot width minus the entity size dot half. Okay, yeah, that's correct. And then the other thing we want to do is kill the velocity. So we want to clear our velocity. So, well, not exactly. I want to clear the x of the velocity. So let's actually go into our vector 2 here. So we have clear, but I also want to just have a clear y and a clear x. So then here we're going to have our velocity dot clear x. Okay, now we're also going to have an else if location dot x minus. Okay, yes, that's going to be correct. If you're less than 0, you have to be 0.0. Then yes, and then we're going to clear x. Yes. Then if location dot y plus. Okay, yep. So set you ring size height, yeah, and then clear y, yes. Else if location at y, yeah. Location at y, okay. Reset you there. Clear y, close you there. Now you're upset. Arena size. Oh, you need to implement deref. Oh, wait, no, you have that. Oh, because it's just width and height. It's not. It's not actually a method. Okay. So this should keep ourselves in the world. Okay, so this is contain entities in arena. We're gonna head back into our main library and there we go. Let's run this and see if it works. Let's give ourselves a little bit faster of a speed. In fact, we should probably give ourselves a like a speed. We need a speed component so that everybody has their speed, if they have a speed at all. So I want to components. Let's create a new speed. S. Okay, so we know that we're gonna have to derive debug, copy, and clone. For our speed, let's give it an F32. We're gonna import deref. Okay, so then we're gonna head back into here. We can maybe take in like our default speed. Your speed. So with component. This is going to be our speed. And this is going to be speed in there. Oh, I forgot. Make you public. Okay, so once that's in there, we need a speed in here. Let's do 0.5. Let's try 1.0 again and see how that feels. Okay, so we have all of that set up. Let's then we want to in randomly walk also query for, so we have this query with component run here. So with component, this is going to be our speed. So that gives us now a second one of these. I guess it doesn't really matter. I don't have to clone. That speeds equals, okay, so query 1. You are going to need to enumerate, so iter enumerate get index and the wrapped acceleration. So we get that. Let okay, so you don't need to be mutable. Okay, so speeds of n, no, yeah. Just a borrow. Then we need to do this too. So we're gonna start here. Downcast mute to speed. Yes. Okay or else. Error downcasting. Okay. Create a random direction, and then this is going to be based upon this speed now. So we want to get a negative dereferenced speed to a positive dereferenced speed. Speed. Or are you double dereferenced? I think you're double dereferenced. Yeah, there we go. Now you are upset. Cannot borrow data and dereferenced. Oh, you need to be mutable? Oh, just downcast. Just downcast. Downcast rec. Okay, there we go. So now we should be using that component. There we go. And our human is much faster. Maybe a little bit too fast. But this is like the power of like doing the ECS with all of these systems. It's like once you get everything set up, it's pretty easy to add new things in and get them going. And if I want to create a whole bunch of these, that's absolutely fine. Also, our size is maybe a little bit big. Let's go back into main and update that. Our entity size is 15. Let's try 5 and sort of like see how that looks. Speed, let's drop that down to like 0.5. And then let's have the number of humans. So humans equals, let's try putting 100 in here. Now I know you're upset. Come in here and we'll do humans is a, yeah, it could be U32, it doesn't really matter. After we do our resources, now we're going to create our humans. We're going to do a for loop. So for, yeah, actually, I think that's exactly right. They're going to just register all these components. Now they're all going to start in the exact center. Should we do that? We can actually do a random. We can do a random because we have this arena size. So let's do, instead of this, do new random range. Our minimum is going to be 0. And then, is that true? Our minimum, wait, this is velocity. Hold on, this is wrong. Our location, okay. So, new random range. For our X, we have a square, so this is gonna be fine. So I want you to be between 0.0, but it's really like 0, because I don't want like the very first, it will like bounce back out. Let's do, make sure that you're half of this arena size. Okay. Okay, arena size is coming in like that. Okay, so this should be fine. Oh no, I think I have that as an entity size. Yeah, we're creating this entity size down here. Let's actually create it up here. And you get moved up to here. And then here, okay. I totally screwed this one up. New, okay. Right, so then you, okay, random range. We're gonna do arena size dot width. Wait, our minimum is gonna be 0. Actually, it's just gonna be the entity size dot half. And then our maximum area is, it doesn't really matter, it could be just one of these, minus entity size dot half. Okay. Now you, oh, because I lost you. So this is gonna be, let's just rename you to size so we don't lose you. There we go. We have entity, move to, okay, so we need entity size should really also do run and copy. Okay, so now we should have 100 of these if we run this. And there we go. Now it's not moving too clearly, but let's find out. Okay, so where are you? We don't need to debug you. And I believe we can just cargo run in release mode, and this should be a lot smoother. That felt like more of GGEZ's just like slow it drawing in debug mode, which it is. Togglebit, rating with a party of 88. Welcome, 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 Togglebit and Raiders. Hello, Otaku Exercise. You're rating and running? Well, I am not surprised. You usually have really long streams. So totally understandable. So hello, hello, hello. How are you all doing today? And how was Togglebit's stream? What was he working on? Is he still working on the what was it? It was the graphics, like implementing his own graphics system. Hello, Gareth. The pixel editor. Oh, nice. Okay. I haven't watched too many of those, but it looks pretty fun. What we've been working on today is getting a, we've been creating our own ECS, which we did that before, but now we're doing it with dynamic dispatch as opposed to static dispatch. And we're going to be creating a sort of like a zombie humans simulator, which is sort of like going to be based on flocking just a little bit, as sort of like a preparation. We're going to do the tutorial that we're going to create is actually going to be that. I love, yeah, that's a great emote. That looks exactly like it's a emote animation of Toggle's hat. So anyways, what we got was our ECS system is to the point where now we can just create a whole bunch of these entities. These are all going to be the humans moving around. And it looks like you're all able to see them pretty easily, so that's nice. Let me introduce you to what the code looks like behind the scenes for this. So in our main library, we are able to add resources in using the more traditional ECS style. We just pass in a type. So behind the scenes, we're using a type ID in a hash map to store them, and then we're using basically a box dyn any. So it makes it really easy for us to just like extract these out too. We can see that down here. I need to get the target FPS out. Well, I just do a self world get resource, pass it in the type that I want, and it gives me an option back. So I just unwrap this at this point because I have to return a GG game result. But then I can just use that. Now I do have to do double dereferencing, and that's because if we take a look at our target FPS here, I have a struct for each of these resources and components that just wraps the data. So I'm implementing deref for this so I can get out what the contained value is, but outside of get resource, I'm getting a reference to the type. So I get a reference to target FPS. So I dereference that, it gives me target FPS, and then I dereference one more time, and that gives me the actual thing that I'm looking for. So it is not super great looking for that, but it works. Yes, I will be putting on YouTube. This is gonna be a free tutorial. I'm not gonna do anything like be putting it behind like a paywall. If I get good at tutorials and like lots of people really want them, that may be something I can do in the future. But for right now, yeah, I'm not gonna do that. Gareth, subscribed with Prime. Thank you so much for the subscription. Thank you. And I hope that you enjoy our kitty cat emote. We have 2 emotes. Okay, so the other thing is our queries, because that's the other big thing in how to like work with ECS systems. Some Bezos bucks, absolutely. I will take Bezos bucks anytime. Although I don't think it'll be enough to get me to space. So the way I query here is I could just do a world.query and then hand it the components that I want to get. That way I can do any number of components, and then behind the scenes, the world is going to make sure that I only get back entities that have those components in them. So we're using a bitmap or a bit so a bitmap, a bit set, a bit mask in order for us to like, hey, do you have both velocity and location? If you do, I want it. We're also using interior immutability, so smart pointers, so RC and ref cells, in order to like contain these. So I only ever need a reference to world, which means that if I need to do this query twice, I'm okay. I'm good there. There's nothing up there anyway. It's fine. I'm sure. Yeah, I actually probably wouldn't want to like go unless it's like I really trust it. But yeah, this is how we do our query. So it's kind of a builder pattern here for this. Then basically I can just extract these out. Cloning on an RC is really simple. It basically doesn't take any extra processing power because it's a smart pointer. It's like practically free. Very cheap. Then I would just loop around one of them. They should always be the same size. So then we loop around them, and then I just do the actual, like, just extract out all the things. The big thing here is like we have to borrow it to get into the ref cell. So that gives us like this ref mute, and then I have to downcast it to get out from the any to the actual type that it is. This is all runtime stuff. There is going to be a runtime cost for it, and that's the cost of dynamic dispatch for us. if I didn't use dynamic dispatch, I wouldn't have this problem whatsoever. And then I'm using this OK or else in order to convert an option to a result, which allows me to use the question mark here and have a good error message. And then it's just basically the actual thing. So all of this is preparation work. And then this is do the thing, like do the if statement. Hey, are we outside the arena? Then go ahead and you know, put ourselves back in. So let's go ahead and clean this up quickly. So I don't need any of you or you. Okay, so you're upset. This is in entities inside of the ECS. Very complex type use. Consider factoring into parts into type definitions. Okay, so yes, it doesn't like this. This is components here. We can actually, we can create a type for this. So pub type components, and then you're going to be this entire thing. And so that way I can then replace you with components. Like that. You are upset at something in the main library. I don't care about that. I don't know why we need you. I have Clippy on the strictest possible setting. So it's keeping me as honest as it possibly can. Okay, so we're using any but not RC in here. Okay, so allow over into. We don't need that. Wait, are we not using custom message? Oh, this is the deck of cards simulator. Oh, I don't need this. I don't need to worry about this at all. This is a completely different project. Yeah. Oh, interesting. Look at this. So if I try to allow Clippy over from over into. Okay, I just guess I just did it wrong the first time. Okay, so to mint vector. Yeah, I know. This is okay, zombie simulator. Okay, so self is copy, so we could just do this then. Because it will copy self and not take ownership elsewhere, so that'll be fine. Nice, you need to do that more. Clippy keeps teaching you. I know, it teaches me new things too every once in a while as well. It's pretty awesome. And I don't think we need RC here either. No. Okay, we don't need that color. Okay, nothing else in here. Okay, that goes away. Okay, we're in main now. We don't need to use this. Okay, everything's gone in there. How about you? Don't need to use this deref. Okay. Don't need to use any of this. We're not using bail here because we're using anyhow? No, using something else. Okay, so variable does not need to be mutable. Okay, it's because it's mutable up here. It doesn't need to be mutable here. It's just like it holds a mutable reference to a location, and I'm downcasting mute from it, but that's fine. Okay, you don't need this type ID here. All right, now it's just yelling at me about spelling. What would you have me do? Well, quick fix. Yes, you're a real word. No more problems. Okay, so I misspelled downcasting a lot, apparently. But I just told it it's a real word, so it's now fine. Okay, so that is everything in here. We can close all of these up now. Okay, awesome. If we run it one last time to make sure it still works. Here is all of our humans randomly walking around and being contained inside of this world. So the idea for this project is they're just randomly walking around, but we're going to add a single zombie. A zombie will probably be different color. We'll probably use like a mouse to add it. So when we click, then that zombie will choose a target, probably something it can see, and then it will just start moving directly towards it. And if it touches any like humans, then that human dies. We delete the human from the world, and then we recreate the human. Maybe we don't even delete the human from the world. We just change its like type to be like, you know, hey, you're not a human anymore. You're a zombie now. And so then after X number of seconds, it comes back, and then it also starts going out. Now humans can never like leave, so that if they can juke all of the zombies, they can stay alive forever theoretically. But I am pretty certain that they're not going to be smart enough to survive for too long. I think that they're going to be accidentally caught into a corner and then just killed en masse. So I think that's what's going to be happening. And then once we get that like the project working and we refactor it to like what we want to be, I'm going to take some notes into like the order in which I want to do videos for the tutorial, and then we're going to record tutorial videos and put them up onto YouTube. So that's the plan coming up. So we're getting closer. There's still some more work to do in this before we can start like actually building the tutorial proper, but I want to make sure that I understand what I'm doing fully first. So with that, I am unfortunately going to have to call it a morning because I have work coming up pretty soon.